Hello everyone, and welcome back to another professional prep video. So in this video I'm going to talk about some of the properties of limits. So note that first of all there are many properties of limits, so I may not be covering them all in this video, but I will cover the major ones that you will need to remember and use the most. So yeah, let's get started. So what I'm going to do, instead of providing like complex mathematical notation with many variables and stuff, I'm just going to show everyone limit laws through examples, actually. I'm thinking that that'll be much more effective for everyone. So let me start by doing this. So let me say, we're going to start out with an addition rule. But first of all, I just want to actually declare a couple of limits in order to help us while we're going. So let's say that we have the limit as x approaches 3 of this function g of x, and let's say that that equals 7, and we have another function h of x, and the limit as x approaches 3 of h of x is 5. So these are completely arbitrary numbers. We just need these in order to go through examples, and you'll see why I wrote these down at the top of our screen here. But let's get started. So let's start out with an addition property. Say that we want to find the limit as x approaches 3 of, and now I want to sum up these two, g of x, my bad, turn that into a plus sign, of g of x plus h of x. So you might already be able to interpret what's going to happen here. If not, that's totally okay. But using our limit properties, there's an addition rule for limits. And that says that when we're adding up these two limits, we're allowed to break it up into the sum of each individual limit. So what I mean by that is that big limit is going to turn into this. This is the addition. This is an addition property of limits that you can break it up like this, but it can be very useful here. So it's something very important to keep in mind, as will be pretty much all of our limit laws, but here. And now, guess what? We have this. This is an h here, sorry. And guess what? Now we have each of these limits. The limit as x approaches 3 of g of x is 7. Limit as x approaches 3 of h of x is 5. So this is actually just 7 plus 5, and which is 12. So rather than rewriting all of this, I'm gonna, for the subtraction property, it's the same exact thing. If this were this right here, if that were a subtraction sign, then just turn this addition into a subtraction, do 7 minus 5, and get 2. That's the subtraction property for limits, so keep that in mind. Another big one is going to be constant property of limits. So what do I mean by that? Say that we have the limit as x approaches 3 of, let's do k. K is just going to be a constant. Keep in mind that k is a constant times g of x. So it's actually just going to be k times that value. That's important to keep in mind, that it's actually just going to be k times that value using this property. So it's just going to be k times the limit of g of x. Well, the limit as x approaches 3 of g of x. So we don't actually have a value for k, so our final answer is going to involve k, but it's just going to be 7k. And so that just says that we're allowed to keep that constant in front and just multiply it by whatever limit we have. And the last major properties I'm going to cover are for multiplication and division. We also have exponent properties, which also work the same. That if you have a limit raised to a certain power, you can just bring the power out and just evaluate the limit. Same thing for roots and radicals, but here I'm just going to show you the multiplication property of limits. Multiplication and also division. So once again, just like addition and subtraction, multiplication and division are very similar. So I'm not gonna have to walk through both of them, but I do think it's important that we see an example of this for going forward. Okay, so by our multiplication property of limits, we will be able to break down. So this is just going to be as easy as addition and subtraction. We're just able to break this down into the product of two individual limits, just like we were able to break it down into the sum or the difference of two individual limits. So in other words, what I mean by that is that that expression is just going to equal the limit as x approaches 3 of g of x times operator there, the limit as x approaches 3 of h of x. So if we just sub in our values, 7 times 5 is going to be 35. And sure enough, that is our final answer. And we can do the same thing for division. Say we have the limit as x approaches 3 of g of x divided by h of x. It's the same thing. You can break it into the quotient of two individual limits. So limit as x approaches 3 of g of x divided by the limit as x approaches 3 of h of x, which is going to be 7/5. So it's that simple. Don't get too used to this, though, because in a little bit we're going to be talking about derivatives, and the rules for multiplying derivative is going to be a little bit more complicated than just this. But for limits, we're allowed to do this. Exponent rule is going to be very similar, where you just have to bring out the exponent. All of these are limits work very, they're very intuitive. You can certainly improvise and get these formulas. They follow lots of just regular algebraic rules. So yeah, that's all I have for you for this video. Please join us for our next video where we talk more about limits, but that's all for this video. Please make sure to subscribe to our channel. Please feel free to send us an email if you have any questions. Other than that, please enjoy your day. I hope you have a good one. I will see you next time. Thank you, everyone.